Okay. So before we get started, any questions for me? Okay.
Yeah, hi Arun. I wanted to know how to submit the assignments.
No, you can just reply back to the same email address.
So we are supposed to submit it, right?
It's all about you. Depends on you. Okay. Whether if you have finished off, just drop me an email, or if you think you are good with them, that's fine. If you think you want me
Okay.
to review them, then you can just drop me an email.
Okay, got that. Thank you.
And I think you guys were not shared the recordings yet, right?
No.
Okay, so I think Shiva is working on it, and he will be helping you very soon, maybe probably within a day or two. He will help you with the recording. So meanwhile, I'll be helping you with the material, whatever the stuff which we do every day, the programs and the respective references. I'll be forwarding it, and Shiva will help you with the recordings within a couple of days. Right.
Okay,
There
great.
is some technical issue, and he will sort it out, and he will come back to you within a couple of days.
Okay.
All right. So we will get started with the programs. I'm sure you guys were able to solve the assignments on the arrays. Okay. Now I think it's good time to get started with the object-oriented programming, because I feel somehow that okay, you guys were comfortable with the basic fundamentals, like how do we write a small program, how do we run it, and the control statements like if, else, loops, while, do while, and the for. And if you have solved those assignments of arrays, then I think you are also good with the arrays concept. So any questions if you have, you can let me know, or you can just write it to me. I'll reply it back. Let's get started with the object-oriented programming. So before we get started with the object-oriented programming, any one of you would like to take a guess what exactly you mean by object-oriented programming, or why do we need object-oriented programming? Yeah, any one of you, if you want to take a guess, you can just guess it, or what exactly, or what was the need to switch to object-oriented programming when, okay, let me discuss the differences between the structured and object, then you guys can come up with the answer. So let's get started. Let me create a package as usual. Hmm, let me create a very text. Say, oh, I'm sorry, it's not a class. It's going to be a file. Now, if you might have observed, I think you might have solved those assignment programs in case if you got a time, then you could have written the programs inside a main method, right? So there was a main method, then within the main method, you have written a program like step 1 or probably step 2 and step 3 and a step 4, right? So this is how the program development has happened. Now the kind of approach what you followed was an algorithmic approach, right? So you have a problem statement. The problem statement is what? The problem statement is to find, or to find the sum of two numbers. if this is a problem statement, then first you think in your mind, probably you won't be writing algorithm because you're used to writing a program. So first, as a beginner, he will first develop an algorithm. Step one is what? Right. So read two numbers. Second step, sum them. Third step, print sum. Then you start writing a algorithm, program, whereas we do it in Java like this. You write a class. Within the class, you are defining that main method. So the kind of development or the kind of approach what we are following is algorithmic approach. So your program development is revolving around the algorithm. Right? You take two numbers, x, y, then you store the values into two variables, then you find the sum, then you print it. Okay, but can I solve all the problems, any kind of problem statement this way using an algorithm? Yes, for every kind of problem statement you can develop an algorithm. But will it be a simple algorithm or it will be a complex algorithm? Now I said it was a problem statement was sum of two numbers. Now I'm going to say the problem statement, bank application. How can you write an algorithm for this bank application? Because bank application consists of so many tasks. The bank application, if you say, there are lot of tasks within that. It's a very big problem statement. It's not a very simple one. I say simple, or you can say small problem statement. Whereas here, it comes to okay. It comes to complex or a large problem statement. That's a bank application. How do I design an algorithm for bank application? It's going to be a very tedious job. So what we do is we try to break the problem. We try to break the problem into small things. Like, say account, loan. So we try to break the problem into small components. Whereas this is not possible using an algorithm. So what we had earlier was the types of programming languages. One, two, and a three. When it comes to the first type of programming language was we call as a structured. You can also say procedure. Or no, let's say structured only. What we do is here your program development revolves around algorithm. Whereas next one was procedure. It is also depending on algorithm. Revolves around algorithm, but can be what we say can be divided. Now I'll let you know how. Now I want to say, hey, let's problem statement is see, for structure I gave the example as your sum of two numbers. For procedures, let's take an example. When it comes to procedure, let's take the problem statement as deposit and withdraw. So what we do is, again we can write a class. I am writing a class as a bank, or you can say, let's say rather than bank, let's say account. Then within this let's not do the class part. We do another approach here. Whereas in C programming, we don't have the concept of classes. Okay. So this is how you used to write. And later on, what we had as procedural approach, where I used to define functions called deposit. Then there used to be a function called withdraw. Then I used to have a main method. Now from this main method, I used to make a call to the deposit and withdraw. So the advantage is you have written the function called deposit and withdraw, and deposit and withdraw are reusable functions. So you have written the code once and you can reuse it again and again. That was your procedural approach. You write a procedure called deposit and withdraw and you keep calling them to use it. So this is a procedural approach. But what exactly the problem with this procedural approach is, you are not able to categorize your work. Of course, there is a thing that you were able to divide your task into submodules, whereas in structured programming approach, you don't have that option. You have to do everything as a part of a main method. Even if you have to deposit or you have to do withdraw or you have to do something, I'll tell you. How do I solve the problem of deposit and withdraw without procedural approach? Now in case if I use the same this approach, the structured programming approach, then I used to do this stuff. Right? Print. You have the option 1 for deposit, then option 2 for withdraw, then enter option, then you will have a switch. It will take the option. If it is your case 1, to write the logic for deposit. If it is your case 2, write the logic for withdraw. See, again this is the algorithmic approach. This is how you do it. Whereas if you have a procedural approach, then you write a deposit separately, you write a withdraw separately, and whenever you feel like want to perform a deposit, call the deposit and call the withdraw. Here you have that option of code reusability option, where in procedural programming you can reuse the code which is written once, whereas in here structured you cannot reuse the code. The thing is, if you have a very big problem, you have to break down into small chunks or small components, and these small components are independent. Now here there is a problem. You deposit into what? Into an account. You withdraw from where? Into an account. So you need a variable. You need a variable called balance, right? You need a variable called balance which is global. This variable is not a part of a deposit. This variable is not a part of a withdraw. This variable is what? Outside, because I should be able to deduct from the same balance and I should be able to add it to the same balance. So where is the security? Here deposit can access the balance, withdraw can access the balance, even somebody XYZ function, if somebody is writing XYZ function, and even they will be able to access the balance. How do you protect it? How do you restrict somebody from you accessing the balance variable? You have a procedural programming approach, whereas in procedural programming approach, you divide your big problem into small problems. And the small problems were in need of accessing the same variable. And you have a balance variable being accessed by deposit, accessed by withdraw, but can you restrict this balance variable being accessed by XYZ function? No, we cannot do that in procedural programming. You cannot restrict a variable being accessed by a function, a global variable being accessed by a function. So these are the problems with your procedural approach. And the other thing is, a big problem is divided into very small problems. There is no intermediate layer. There is no intermediate layer. You are completely going on dividing into very small minute problems. But there should be something in the intermediate layer. So that's where your object oriented comes into the picture. You got your third one. Now when it comes to your third one, you got your object oriented. What you do is, if I say the problem statement as a bank, right? If I say the problem statement as a bank application, then we start breaking down into components. Let the component is account. Let the another component is customer. Let the another component is account. Oh, sorry, account is done, right? So we have another component as a loan. So we are dividing. The bank is divided into three components. Again, now what happens within the account? Normally what it does, deposit and withdraw. So this is how you are, again, you have an intermediate layer in between. What do you have inside a customer? Customer, he can, or what else can do? Or you can say, we have customer. What do you have in a loan? Within the loan you have, apply for loan. Pay EMI. Calculate EMI. This is what object-oriented approach. And here, I can put the variables. What is account consists of? Double balance. So what I'm doing here, only this balance can be accessed by your deposit and withdraw. Nobody else can access this variable. Double loan amount. Who all can access this loan amount? Only these methods. Apply for loan, pay EMI, calculate EMI. Only those methods can access the loan amount. Nobody else can access it. And you are grouping it, right? It's not that, okay, the big problem is divided into very small problems. You have an intermediate layer in between. So you are categorizing, you are breaking your problem and you are dividing into categories, and each category again has some tasks in it. Now it is very easy to distribute the work among a group of people. You can divide the work. So you can say, hey, your team will take up this loan class and finish it off. Other team will take up account class and complete it. So the work distribution will become much easier, right? Yeah. Any questions, or is it everything going good, or you have any questions on it? Okay. Hey, are you guys, can you hear me?
Yes.
Okay, okay, okay. And you're also able to see the screen, right?
Positive.
I'm sorry? Okay,
Yeah.
okay, okay. So let's start solving some problems. Alright. So here we go. Let's create a class. Okay. So first let me create a class called what? Customer. Or okay, let's do something called binary calculator. Now within this binary calculator, so binary calculator is a which gonna perform the operation of two inputs. So let's say int first number, then let's say int second number. So I have two variables. Now I'm adding. There are two variables inside a class, and these variables are referred as instance variables. So I'm going to talk about them later. These variables are referred as instance variables. I got two variables. Now observe this. Right click, source. I did the right click in the class. When I say source, getters and setters. So I did that. What do you see then? So the get method returns the value of the variable. You can add a comment this way. / asterisk asterisk enter. So you can add a comment over here. So that indicates that it returns something. And just write down the value of variable. And here assign to variable first number. Or let me specific, is assigned to variable, but which variable? Assigned to instance variable. If you see, the instance variable is first number, and you see the parameter. The method takes an argument. The method takes an argument, and that is also the method takes an argument, and that's also first number. So both the instance variable and parameter are sharing the same name. So we differentiate it using this keyword. Now this dot first number refers to instance variable, right? The simple first number refer to local variable, or you call it as an argument, method argument. Right. Now one method is to read the value of the variable, and other method is to set the value into the variable. This is fine. So what next? I would like to define operations here. So I would like to define a method called sum which returns an integer. Return first number plus second number. So you have one method called sum. This is a method it returns sum of first number and second number. Similarly, I would like to define the rest of the operations. Return first number minus second number. Then I have the other one for it. And it is very simple. Put a forward slash asterisk asterisk, press the enter key to get the comment. Public int, you have the sum, you have the difference, you have the product. Then what next? Yeah, you can say reminder or so if you observe carefully, you have defined a class with some variables and setter and getter methods. You got a class with two variables, setter and getter methods, and you have some operations, sum, difference, product, and reminder. Right. Now you can take another class, or in the same class you can define a main method. In the same class you can define a main method, but instead I recommend to go with another class with the main method. Now what I would like to do, I would like to invoke the methods of the class binary calculator. I would like to invoke the methods of the class binary calculator. So this class got the methods and I would like to invoke them. If you want to invoke them, first you need to allocate the memory for them. So I am creating an object for binary calculator. It's going to be a simple task. You need to write the class name first. You don't need to write everything. Bi control space bar. Then again you need to give a variable name. You just need to do control space bar. So binary calculator, if it seems to be very big, you can pick the calculator. You think calculator is also very big, you can just say BC. Then again, so you created an object. So here we call it as the new keyword helps in memory allocation. So you can also call it as object created. This is syntax for object creation, or you can say memory allocation. So what happens when you allocate the memory? What happens when we allocate the memory, or what happens when we create object? When we create object, memory allocation for instance members takes place. So now the first number and second number of the binary calculator, there is a physical memory allocated to them. So what is the physical memory the integer takes? Integer takes 4 bytes of memory. Integer takes 4 bytes of system memory. Then what should I do? Then I am giving you the options. Okay. What operation would you like to perform? Then here comes char option. Oh, we need to, if I want to read something from the keyboard, what do I need? I need to create a scanner object. So I'm creating an object of the scanner. The system.in represents the keyboard. So we are asking the scanner to scan the data from the keyboard. But we don't have a method to read a character. So I'm reading a method called next. I'm calling a method called next, which will read a string. But I'm not going to enter a string. I'm only going to enter a character. So from the string, I'm picking up the character which is at the position 0, the first character. Then comes here. Enter first number. Then where do I store this first number? Focus here. bc dot set the first number, scanner dot next int. So what I'm doing here? I'm reading a character. I'm reading an integer. I'm reading an integer, and that integer I'm passing it to the setter method, so that whatever the value I enter, that goes into the first number variable. Similarly, what next? Enter second number. Then, depending on your operator selected, perform the respective operation. Oh, if it is your case 1, then it's very simple. So the sum is then binary calculator dot sum. Then you have a break. Now sum is what? Sum is sum. But sum of what? So here we go. Sum of bc dot get the first number and bc dot get the second number. So done with the first. Difference of, then here we go, product of, then you say reminder when Done. In case if somebody enters anything other than that, just give a message, invalid option. So let's run this. Word operation. First number, second number. Now, then I have a complaint. And the complaint is that I already did binary calculator earlier in a very simple way. Look at this. When I can't finish off the program in a single class inside a main method, see how simple this logic was. Then why I am complicating it? Why I am complicating it? Now, today, in the previous session, I did the arithmetic binary calculator inside a main method with some number of steps as 10. Then why I am choosing out the odd way where I have defined two classes, where I created a class with variables and methods, then I am creating another class, then why I am invoking those class methods over here. This seems to be a very complicated way, right? You know, the task has been increased. Rather than making your job easy, your efforts are more here. So this is a very simple problem where I'm trying to, you know, apply object-oriented approach. But when you look at this object-oriented approach with a larger perspective, with a what we say, a very large complex problem, when you try to apply it for a complex problem, then you will understand the real benefit of object-oriented programming. And one more thing I would like to say, okay, before I go there, any questions for me on what I did so far?
No one.
Alright. So I have a question for you people first. What do you think of this program, the two programs I have written? You see one binary calculator, you see another one run binary calculator. Do you like to comment anything on it? No, what exactly the advantage? Forget about object-oriented programming. So what is the scalability of this program?
I think,
yeah, go ahead.
Yeah, I think because we declare two classes, we can make any changes we want in those classes without having to change the main method.
Yeah, perfect. Your answer is perfect. So if you want to do anything changes without having impact, we don't have an impact on each other, right? When I'm modifying one, you don't have an impact on other. But why exactly I need this kind of feature? Why should I look for this? Why should I ensure that when I modify one, that should not have an impact on another? Why should I target this kind of programming approach? So you have the answer.
Right. I feel it's like in a real-time environment, many people will be working on the same program. So,
Perfect.
you know,
yeah.
to avoid mistakes.
True. So your answer is correct too. Right. I'll let you know the other one. You might be aware of, but I just want to tell you. See, now if you look at this binary calculator program, do you see any user interface? By looking at this program, can you tell me how you're going to run the program? Are you going to run the program on a command prompt? Are you going to run the program on a console? Are you going to run the program on a graphical window? Are you going to run the program on a web page? By seeing the binary calculator, if any one of you can take a guess that, hey, this program I'm going to run it on a console, or I'm going to run it on a Windows, I mean a graphical interface, or I'm going to run it on a web interface. Nobody can say that, right?
No.
You see, there is no system.out.println here, or no what we call it as Windows-based interface. There is no frame, there is no applet, there is no buttons. You don't see anything over here. So by looking at this binary calculator, no one will be able to interpret where I'm going to use this program. So this program is scalable to a console-based application, to a web-based application, and also to graphical-based application. So unless and until I see this run program, I cannot tell that, oh, this is going to be a console application. So when you write a program, you have to ensure that that is scalable. So whether you can use it anywhere. You can use it on a web, you can use it on a graphical window, or you can use it on a console. So that is what I ensured that, my program, if I use this binary calculator today, I have my environment, I have my execution environment as console. Tomorrow it can be a Windows. Day after tomorrow it can be a web. So I have that scalability option available here. Fine. So let's do some more examples, right? So let me define. Now I have a binary calculator. Now this is binary calculator of what? Two natural numbers, or you can say two integers. This is a binary calculator for two integers. So let's define my own data type. Let's define my own data type. So let me list it down here again. So what do we mean by rational numbers? Now what do we mean by rational numbers? We got the one. A rational number comprises of a numerator and denominator. It consists of a numerator and denominator. And we don't have any data type in Java which represents that. We have another one called complex numbers. Again, there is no data type for them. We have a real part and imaginary part in it. But Java don't have it. Not only Java, no language, programming language got a data type for rational numbers, or no data programming language got a data type for complex numbers. So we start defining our own data types. Let's start defining our own data types. I'm defining a class, let's say rational. So I'm defining my own data type. Now defining a class. Let's this class consists of private int numerator and private int denominator. Now right click, source, getter and setter. That's it. Now this class acts like a data type for me. Right? It acts like a data type for me now. I say rational. It's a data type for me now. Right. Data type whose physical memory will be what? So every data type should have some memory. So what is the physical memory for this rational data type? Sum of the members, sum of the instance members, sum of the memory of the instance members, sum of the memory occupied by instance members. Then I define another one, rational binary calculator. Now within this, what I'm going to have? Private rational first. So again I'm going to say private rational second. Then again I'm going to have getters and setters to it. This is one option. The other option, we don't need to do this. You can simply define your operations here. I mean, I'll tell you what. Now I have this, right? I can define operations now. the way I did it for the arithmetic binary calculator. My return type is going to be a rational because when I add two numbers, I get the result as a rational. So this is one option. This is one option. Right. The other option is I can simply do this. Earlier my methods were no argumented. Now my method is going to be a argumented. So let's do the easiest part first. Product is easy to do. How do we find a product of two rational numbers is, suppose if you have your first rational number R1 is like this, 2 by 3, R2 is your 3 by 4, then how do we find R1 times of R2? R1 times of R2 gonna be 2 times of 3 then 3 times of 4. This is what your result. So let's do it here. So let me take a new variable called rational result. Then result dot set numerator. What is the numerator of the result? The first numerator multiplied with second numerator, that gives you the result numerator. Then again the first denominator multiplied with second denominator. So I did a simple one. Alright, this is what the product. Okay. So similarly, what I suggest you guys is figure out how to perform addition, how to perform subtraction, and how to perform division. Then let me discuss how do I execute this rational binary calculator. Run rational binary calculator. So if you see, I have what in total is, I have a class called rational which acts like a data type. I have a class rational binary calculator which got all the arithmetic operations. Then I have a run rational binary calculator where I'm going to create an object and invoke the methods. Here. Yeah, created an object. Now I should read the values. But before I read the value, I should read the values for whom? Two rational numbers. So let me create an object for rational R1. Then as we all knew, in order to read something from the keyboard, I need a scanner. And while creating the scanner object, I specify system.in System.in represents keyboard, so we are asking the scanner to scan the data from the keyboard. Here we go. Enter numerator. Then R1 dot set numerator scanner dot next in. Now similarly we do it for R2. Oh, we missed out another one. We also need to read the denominator, right? So enter denominator, then R1 dot set denominator scanner dot next in. So repeat the steps for R2. Then you have two rational numbers. Now you have a rational binary calculator object. Then as usual, you ask for the operator. Ask for the operator. Then once you found the operator, you got an option. Now here, it's not so easy. Okay, here there is a slight change. You maximize the window. Okay, I have the product one, right? So let me do that. Okay, let me take a variable outside because this will come handy for all the operations. Focus, this is something important. So what do we have? RBC, yeah, dot product, pass the first rational number, pass the second rational number. The first rational number is R1, the second rational number is R2, and that will give you the sum of, that will give you the product of the two rational numbers, and the product of the two rational numbers is stored into result. Now I'm going to print it. So the product is our result, right? So result dot get numerator. I'm just displaying in the P by Q form. Okay. So there is no just P by Q form, numerator by denominator. Run this. So you got a numerator 2, 3, again a numerator 3, 4. So what operation would you like to perform? I had only one. So 2 times of 3 is 6 and 3 times of 4 is 12. Right. That's what we have, right? So when you look at here, 2 times of 3 is 6, 3 times of 4 is 12. This is your numerator and this is your denominator. So similarly, you can figure out a way to perform the addition, subtraction, and the division. Yeah. So any questions on this program before I move further?
Yeah, Arun, I was wondering why did you keep the operations in a different class like calculator and not in the class rational number?
Yeah, perfect. Okay, but yeah, your question is valid when you look at your previous example. In your previous example, There was only one binary calculator, then within the calculator itself I was declaring the variables, right? In the binary calculator itself I was declaring the data. But here,
Yes.
why, whereas if you look at the current example where I have two things, one is rational.java, other one is rational binary calculator. Now if you see, I want to perform the sum of what? Two rational numbers. Is your rational numbers a standard Java data type?
No.
No. Since it is not a standard Java data type, I would like to create my own data type. There is no data type existing called rational. So I want to define my own data type. I want to define my own data type. So I define it. So within this itself, if I start defining the operations, then it is no longer a class which is representing a data type, because it also got operations in it, right?
Okay.
So I want to be specific. There is no Java logic behind it. It's only the English grammar dictionary logic in it.
Okay.
I want, this is representing, if I say it as a rational, I want it to be specific to data only. I don't want it to involve the operations.
Okay.
If I involve operations, it's no longer a data. It's also got some operations which are doing some calculations. It's like a binary calculator, right? So that's the reason because the word in itself indicating rational. Rational indicates it's only data. It doesn't indicate any operations there.
Okay.
Then I define another class called rational binary calculator, where I was performing the arithmetic operations on the rational numbers.
Okay.
It only goes with the name of the classes I have chosen. Because of that particular reason, I separated that. Rational, I want it to be specific to data type. The other advantage is, in some other cases, if somebody want to use a rational data type, suppose if I combine both these classes, and somebody is interested only in the data type, not in the operations, then what happens? For him, it doesn't make sense, right? All other operations.
Right. Right.
Though he can write a class, but he will be having the other operations which is of not, he don't need them. So now, if somebody else, if some other application want a data type called rational, they can just pick this class and they can make use of it. Use it.
Okay.
Exactly.
Okay.
So this is one. So similarly, I would like to add one more assignment for you. The way you have a rational calculator, let me quickly add one more. I just say it as a complex. Then your complex got two things: private int real, private int imaginary. Then right click, source, getter and setters. Then very quickly, then we go here, class, complex binary calculator. Then let me define a method. Public, the return type complex. You got a method sum, 6 arguments, complex first, complex second. Now let me define what do you mean by complex numbers. So here we go. You got real number. Okay, so if you want to see let's see how the complex number look like. C1, 2 plus 3i, C2. Anything it can be. So this is how the complex numbers look like. Then in case if you want to find the sum of them, you want to find the sum of C1 plus C2, then you're going to say here 2 plus 3. The real part is added to the real part and imaginary part is added to the imaginary part. So this is how the complex numbers are added. Then here we go, complex result new complex. Then result dot, what is that? Yeah, set real is first dot get real plus second dot get real. Then result dot set imaginary, first dot get imaginary plus second dot get imaginary. It's done. Similarly, figure out how do we perform difference, how do we perform product, how do we perform the division of the complex numbers. And here we go. I said run, okay. Run complex binary calculator, and I got a main method over here as usual. Then I to read the data I need a scanner. Then I need two complex numbers. Then I want to read the data for them. Enter real. Then one dot set real. Scanner dot next thing. Then goes enter imaginary. Then one dot set imaginary. Scanner dot next thing. This is one complex number. Let's have another one. 2. 2 dot set real. 2 dot set imaginary. Then here we go, the complex object for complex binary calculator. Then I'm giving a SISO, asking for enter a character, right? Okay. Enter the operation. Enter the operation. When you got your switch case, we write an option here. Then you have the multiple cases. Case plus, case minus, asterisk, what division, whatever you want to have. Then I'm taking a variable complex result here as null. Then result equals CBC, the object dot, what is the method? Sum. Pass the first complex number. Pass the second complex number. That gives you the sum. Then print it. Again, I want to print it in the form of complex number, that is a plus I bi. So here we go. The sum is result dot get real then result dot get imaginary plus I at the end. To run this, real, imaginary, real, imaginary. What you look like perform? 2 plus 3, 5, 3 plus 4, 7, 7, 5 plus 7, 9. Right. The same example, but the kind of logic you're going to write will be different. Otherwise, the way I approach the program is completely same. Alright, so before I move further, I have a question for you people. Why I am doing complex result equal to null? Why I am not doing new complex? It's not only in this, even in the previous example also, in the rational also I did the same. Why I am not doing this? Why I am doing it here null? Whereas in the previous one, I did here new complex, 2, I did new complex. But for result, why I am doing null? Why I am not doing new complex?
I think because when you write complex result is equals to new complex, the data values, the instances inside the complex may get garbage values.
I didn't get you. Can you come again?
Okay, so before the switch operation, if you write complex result is equals to new complex
Okay.
maybe the data value or the instances inside the class result may be assigned garbage values.
Okay, let's do it. All right.
Okay.
It's still perfect, right? Okay.
Mm-hmm.
So, well, okay. So let me add a point here. As you brought up the discussion of garbage. In Java, there is nothing called garbage values. Every data type got a default values. In Java, there is no concept of it. There is nothing called in C and C++ programming. If you declare a variable and if you don't assign a value, it takes garbage values. Whereas in Java, it is not. There is nothing like that. We have a default values for all the kind of data types. When I say, if you declare an integer variable, oh, let's go back to, we have a document called query.txt. So default values. So default value for all the int types is 0. When I say all the int type is your integer group. I hope you guys have gone through that data types reference I have given you on the last day. For integer group, for 40 it is 0. For floating group it is 0.0.
Okay.
Right. So these are default values, and for Boolean the default value is false. To declare a Boolean variable, the default value in the Boolean variable is false. So you are thought of assuming that it may assume the garbage values. So that is wrong, because in Java there is nothing called garbage values. It is default values are there. Yeah.
Okay.
Anybody else would like to take a guess? Pradeep, Priya, Lakshmi. Okay. Let me do this part. See here, if you see, go back to the complex binary calculator. What are you doing here? Somebody is passing you the first number and second number, right? Somebody is already passing you the first number and second number. So you are getting the real part of the first and real part of the second and storing into a result.
Right.
Again, the imaginary part of the first and imaginary part of the second, summing it and storing into a result. You already created a memory allocation for result variable, right? See, you already allocating a memory for allocating memory to store what? Store the result. So you are finding the sum of the first real and second real and storing into the result real. So already there is a memory location which is pointing to the result, right? So you are returning that result. So you're returning, when you say return result, you are returning the address of that memory location. We are returning the address of the memory location which is holding output. So when you are returning this address is being assigned to this variable. So I didn't allocate a new memory because it doesn't make any sense. Why should I allocate a new memory again? If I use new operator here, what I'm doing? I'm allocating the memory again. But why should I do it? I have to point to something which is already existing. In the complex binary calculator, I already allocated a memory and I stored my result into it. I am returning the address of this from here. In the main method, I am declaring a reference. I don't want to allocate a new memory again. So I just have a reference which is holding nothing. Here, result is a reference of type complex holding nothing. Now what are you doing here? Now the result reference of type complex holds the address returned by the method. So that is the reason I was able to get the output over here. One more thing. Even if I do this, what happens is you are making your result point to a new memory location. Now the moment you come here, now your result which was pointing to new memory location will leave that and it will hold the address of this. You understood the point here? Now here you are allocating a new memory and your result reference is holding that memory. But the moment you come across this line, the moment you come across the line number 37, the moment you come to line number 37, what happens? It will lose the address of what it was holding earlier, a new memory allocation. It forgets that address, it holds the new address what is written by this method. So it doesn't make sense for me to allocate the memory for this one here. Just be a reference holding nothing. Whatever the address it returns, it will hold it.
Okay.
Right? And one more thing is here also. You got your first, you got your second. You didn't do anything first equal to new complex and second equal to new complex. The reason being, you are allocating the memory in the line number 15, again allocating the memory in the line number 22 for first and the 2, and when you are calling the function here, you are passing 1 and the 2, right? So whatever this 1 and the 2, the address, whatever the 1 and the 2 are pointing, the first and the second also points to the same address. Points to the same address. So here, first is a reference going to hold the address reference, or we can call it as a first, we call it as a formal parameter. This is not actual parameter. First, a formal parameter is a reference going to hold the address of the actual parameter, alright, which is used when function is called or when method is called. That is, when you are calling the method from the main, whatever the object you are passing, the same address if this one is pointing to some address, right? The same address is also being pointed by this first. Similarly, whatever the address this 2 is pointing, the same address is being pointed by the second. So here, first and second are called as references, whereas 1 and 2, they are objects because they have pointing to some location. But here, they are not pointing to any location unless and until somebody assigns them something. Similarly, the result is an object, whereas the result over here in the line number 34 is a reference. Correct. Is this clear? Because this concept is very, very crucial, because this actually, if you understand this thing better, you will not waste a lot of memory while creating the objects. There's any questions, or everything is good?
It's good.
Okay, so let's move on. Yep.
You did. Hi Aaron, is the variable and reference is the same one? Because here it's the complex result is act like a variable here, right? The equal to null, it means the variable. So variable and reference is the same one.
So let's make it very clear now here. So when it comes to variables, we use the term variable only for the standard data type. If I say here, let's go. What is numerator? I call it as a variable. What is denominator? I call it as a variable. Okay. Whereas, what do you call R1 as? I don't want to call R1 as a variable, because it's not your rationally not your standard data type. Rational is not your standard data type. So let's not call it as a variable. So
so it's a reference.
Yeah, it's a reference. But since you use a new operator here, you can call it as a R1 as an object. There is nothing wrong in calling it as a reference, but since it is been assigned to a new operator, so you can say it's an object. Okay. Whereas here result, we are not calling it as an object because there is no memory allocated to it. So I'm calling it as a reference. Okay.
And one more thing, if the user ends the number as a complex number, how we will do that one?
I didn't get you. Can you come again?
The user enters the number as a complex number itself, 2 plus 3 plus 3i. If the
he cannot do that.
Okay.
Because that's word, right? So if you look at this rational, what do you have? Numerator and denominator, right? So when you are reading the data also, that's the reason if you see, enter first number, I'm picking up an integer and setting it. I'm picking up an integer and setting it. So he cannot enter anything input as a 2 plus 3i or 3 plus 4i. He don't have that luxury. He should again input values. That's the reason. See, that's the reason we call it as an abstract data type. So what do you mean by abstract data type? Means he knows that when he gives some input, he gets the output. Let me run this again. Run binary calculator, or not run rational binary calculator. See, we ask him to give the input this way, right? And we provide him the output this way. Alright? So he is not, means we are not letting him what is happening inside. We just throw him the output. So that's the reason the kind of data types if we are constructing our own data types, we call them as abstract data types. Okay. So why do we call them as abstract data type? Because we don't let him know how it is being written inside. So for him, again it will be the standard data types only. Integer, 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 integer only. Okay.
Okay, so they cannot type as a rational number, right?
Yes. So that's the reason the data type of which I constructed, this one, we call it as an abstract data type. He don't know how it is being implemented. For him, again, it will be the same. The math, what he studied in the school, the integers. He operates in terms of integers only.
Okay.
We also have the possibility in case if you want to, if you want the customer to enter it as 2 plus 3i, then what you need to do is read it as 2 plus 3i, read it like a string, then you break it into pieces. You understood now? So you are increasing your burden. As a programmer, read it as the customer entered, read it as a string, break it into pieces, store the first part into real, store the second part into imaginary. So that's something, you know, which a programmer has to do a lot of stuff, right?
Okay.
So rather, I don't want to complicate that, because what is the big deal in reading a string and breaking into tokens and again storing it? That is all something you have to do it.
Okay.
Yeah. Any other questions?
No, Arun.
Yeah. All right. So I think so far we covered all the, we learned how do we break that problem statement into object-oriented concepts. So I like to have you guys to complete these assignments, whatever is left. I didn't left much for you people. The only thing is you just need to add some operations to the every data type, every calculator. All right. So what we do is in the next class, we will talk more about object oriented. Today we only spoke about the instance members, whereas in the next class we also talk about the static members, and we pick up the what do we say? Today we were doing just calculator kind of stuff. In the next one we will be discussing a bank application with the object oriented concept. So I would like to stop here. If you have any questions, I can take it forward. Otherwise we'll stop here. We'll catch you in the next session.
Yeah, Arun?
Yeah.
Hello?
Yes, I can hear you.
Yeah, I had a question on an unrelated topic. It was about the scanner method, scanner class actually.
Okay.
So when I am trying to create a new object of the scanner class, suppose I'm writing scan equals to new scanner system.in.
Okay.
So instead of the so here in the program that you have written, you have named the object as scanner, right?
Yes.
I usually call it scan.
Okay.
Okay, so that's the only difference. But when I do it, I get I don't know what to call it, sort of a warning sign which says that it's going to leak or something. So I don't know what it means.
All right. So the thing is, you are allocating the memory to it, right?
Mm-hmm.
When you are allocating a memory to it, so what exactly this scanner will do is, it tries to read the data from your input device, right?
Mm-hmm.
So you are allocating a memory and you are trying to read. That is, you are opening the console. So what do we call it as? You have your input and output devices. So here you are opening your input device, right? So what happens is,
right.
The problem is you just need to do at the end of the day, at the end you have something called scanner.close, right? So the thing is, you have opened a resource, and if you don't try to close it, there is a possibility of memory leakage.
Okay.
Right. So that is what exactly happens is, actually when your program execution stops, right?
Mm-hmm.
All the resources will be closed. So you don't worry about that. But normally that is a warning signal for you that it is better when you have opened a resource, it is better that you close the resource too.
Okay.
So it is a good programming practice, or it is a good convention that every time you open a resource, it is advisable to close it too.
So it goes for every abstract data types as well. I mean, it's
not
recommended
that every
to close
abstract
them.
data type, because here it's been associated with a keyboard, right? You have opened a keyboard to try to read it.
Okay.
And in case if you are trying to open a file also, see here instead of system.in, you can write lot of other options. You see something called file source, input source, right?
Right.
Yeah, in the file source. That is, with the help of scanner, you can not only read from the keyboard, you can also read from a file also.
Okay.
So when you have opened a file, it is your responsibility to close it too.
Oh,
Because
okay.
the file can be accessed by some other people also, right? So files will be there. Files on your computer are not concurrent access. At a given point of time, only one person can use it.
That's right.
And you open the resource, and if you don't close it, the other people will be in a waiting to use that resource, right?
Okay.
So it is better you have to close the resource. But
Okay.
when, as long as you are not on a networking programming or not on a resource, shared resources, you don't worry about that. But this kind of things matters when you are using a shared resource. Like in the future, you're going to use a database, right?
Right.
So in the database, everybody, you will not have a database for every individual computer, right? You will have a database on a server and all the people try to connect to it.
Right.
So it's a shared resource being accessed by many. So in that case, if you are trying to open a connection, once your job is done, it is advisable to close your connection.
Okay.
So that was the problem there. So there are some, I don't know what version of JDK you are using. Because of that reason, it is showing you that warning. But in my one, it will not show. Even if I use scan also, it won't show me that warning because of the version of JDK I am using. I mean, some versions will not throw the warnings for. See here. You don't see any warning over here, right? Though I use scan.
Right. Right.
So you can ignore it for time being. But
Okay.
remember the point, whatever the point you brought up, the concern you raised up, that is very, very important. Whenever you use a shared resource, it is advisable that whenever you have opened it, it is better to close it. Now for time being, how you can fix your problem in your computer is simple. At the end, you can say, that will take care of. Yeah. Any other question? Alright guys, okay. So please try to finish off the assignments on time, and when it comes to, it's up to you whether you want to submit it or not. If you want me to review it, you can just submit that assignments. In case if you think that okay, you want me to review it, otherwise that's fine. Alright. So I would like to stop here. We'll catch you in the next session. Right. Thank you.
Thank you, Arun.